Dear external examiner and our own apiculturist, Dr. M. R. Srinivasan, respectable head of the department, who is away for some official commitments, Dr. Murugan, dear PG coordinator and deputy PG coordinator, budding entomologist of this department. We are very glad to receive the external examiner come specialist of an apiculturist, formerly controller of examination at UAS Bangalore, and then now he is advisor to the uh, education directorate, who is here to deliver a special lecture on bee pollinators for sustainable agriculture crop production. So crop production and bees are inseparable, as you know. Their contribution is very, very essential by all means for the productivity. And I hope the expertise of our external examiner as a apiculturist will inspire you, enthuse you in one or other way. So fortunately, we have some of our own PG students who happen to be the specialist of researchers on bees. Of course, he has got a very wide biodata. If I read, then that will take half an hour. So he has got a wide experience on Sericulture College. Chintamani started his service, and then again as a iCreep sunflower, I happen to have his own friendship since 20 years back. At that time, I was also in iCreep oilseed sunflower. So we had a wonderful association on the personal front as well as on the research front. So then he served as apiculture department heading the honeybee department and then controller of examination, etc. So he is a very sincere, honest person. So normally any external examiner he invite us and vice versa. It is going on that rapport and the expertise, everything has been shared. So he has also headed so many advanced researches as an entomologist on molecular front, on genetic front, etc. So anyway, however, we find it very apt that the present heading and his lecture will benefit in one or other way for the PG students of this department and for entomologists as well as in anywhere in our campus. So we are very happy to invite you, sir, to start your lecture and enthuse us.
Good morning to all of you. Vanakkam to all of you. So I am Dr. K.S. Jagdish. So as sir already pointed out, I have to be expressing my gratitude to Tamil Nadu Agricultural University Coimbatore for giving me an opportunity to share my small iota of knowledge, especially with regard to pollinators and IPM, and rather than eco-friendly IPM. So again, as he already told, I reiterate once again, myself and Dr. Umapati sir were united because of the crop sunflower, which is on the right side. And again, I am also blessed or glad to be associated with Dr. M. R. Srinivasan sir, because again, the honeybee on the sunflower. So again, we don't know because there is a saying in Bhagavad Gita, Runanubandha Bandha Kaunteya Pati Patni Suta Alaya. So it doesn't restrict only to Pati Patni or Alaya. It also reflects in our association, in our karma bhumi, that is in our career or in our education or in our research. Somehow God would have blessed us to be associated in one way or the other. So again, I thank the Almighty for giving me an opportunity to speak. So first of all, as the title tells, it is a confluence of both apiculture and entomology. So there is no difference. Only because of administrative reasons, UAS Bangalore or TNAU might have told you are an apiculturist, you are an entomologist. But again, the insect world is the dominant world. 66 or more percentage of all members of animal kingdom belong to the insect world. So with this brief thing, I just want to again I go back to a little bit of philosophy. I know you are too young to receive philosophy, but again, you would like to do Doctor of Philosophy. That is a different issue. So among all the notorious creatures on the planet, I think human beings are the most notorious. That is what it is not my saying. It is from a philosopher called Joseph Wood Crutch. Okay. And again, there is a constant struggle between human beings and insects. So both of us are fighting for the same biological resources, the same shelter, the same fiber, the same food. Both of us are competing. So in that sense, Forbes in 1915, more than 100 years back, he has told that this will continue further. Again, there is a conflict of interest. So for the same resources, we keep fighting. And again, I know most of you are already aware what is the importance of pollination. Pollination is again, especially with regard to angiospermaceae plants or the cross-pollinated plants, what we call. The pollination is a process in which the male gamete or the pollen is going to be transferred from the anthers to the stigma of the female reproductive organ of the flower or the plant, which is again that process we call as pollination or cross pollination. So as far as the agriculture is concerned, it is an important asset or a biological process which leads to the production of fruits, the production of the seeds, without which, almost 70 to 80% of the angiospermaceae plants are dependent on a mediated cross pollination. I mean, wind is also a mode of pollination, insects are also a mode of pollination, birds are also a mode of pollination, bats are also a mode of pollination. You can't deny that fact. And of course, the key role is again made through insects, particularly the bees. And there are more than 20,000 species of bees on this planet. And most of the bees are ground dwelling. They are again, they nest in the soil. But we are all much more concerned or bothered about the managed pollinators. That is, the domesticated species which you can manage, which you can manipulate. Again, they all comprise of Apis species or Tetragonula iridipenis, which is the stingless bee. Of course, insects will be considered as the most important because they are responsible for 80 to 85% of all pollination. And again, within that, a lion's share of that is attributed to the bees. Okay, I don't mean honeybees alone, there are bees. Okay, and the biggest groups are solitary bees, bumblebees. Of course, we are from a tropical world, we are not much concerned about bumblebees. But again, in parts of Northeast India, bumblebees again are important as pollinators. You have to again underline that fact because India is such a vast and diverse country. You have got temperate climate, you have got tropical climate, you have got subtropical climate. And again, the solitary bees, honeybees are major players in the tropical and subtropical world, contributing immensely to the cross pollination. And of course, if you take some of the facts and figures, 35% of global agricultural land and they support 87% of our leading food crops are the food commodity production producing crops. And pollination dependent crops are 5 times more valuable than those which don't need pollination. Again, you may think about cereals and millets. Of course, cereals and millets are not dependent on bees or insect pollinators because they have a self-pollination mechanism. I am talking about the pulses, the oil seeds, the spices, the medicinal plants, the aromatics, and horticultural crops, including fruits and vegetables. Because every day in and day out, we are immensely dependent on all these crops which I have listed for our nutritional and food requirements. And again, if you in USA they have quantified the direct or indirect effect of pollinators. It is contributing to almost 577 billion US dollars per year. That is a huge, huge amount of money. They have quantified that. Kindly look at that. It is not a vague presentation. It is a estimated published information which I am putting forth in front of you. And again, of course, the dependency on pollinators has increased by 300% in the last 50 years. Again, you may wonder why. Because of the pest menace, disease menace, viruses transmitted, pathogen attack, insect pests, most of the horticulture is changing its face. They have gone towards precision horticulture in glass houses, greenhouses, polyhouses, controlled environments. They are forced to cultivate the crops. And in that situation also, they are dependent on bumblebees or stingless bees for pollination. So that also you have to take into cognizance before you proceed further. And of course, if you take USA in 1895, the USA, to avoid crop failure, they used to, there was a immense or practical application of honeybees in most of Virginia and other parts of apple growing areas of the United States. So, India also cultivates apple. If you go to northern states, Himachal or Jammu Kashmir, apple is again a major value earning crop in those states. There also, again, mellifera plays a major role. And again, if you take the overall apicultural map of the country, I think a mellifera, you are aware, is a North Indian species. Serrana and Tetragonula are South Indian species. So again, the India is such having such a blessed with so much of variability, diversity, and that itself is the strength of pollinators also again. So again, when we talk about this, this is just depicting you about the way the hexagonal cells are there, how the bee does its work, its foraging strategies. It is just to show you. And this is one of our lab assistants who could just put the queen bee under his chin in a queen cage, and you can see all the daughters of the, that is the worker bee force, will be entirely crawling all over his body. So this is just to show you that bees are friendly and we have to be friendly. That is B friendly. Okay. And again, if you go for some other facts, I know I am bombarding you with lot of facts, statistics, without which it will not be convincing, because you are all science students. Only if you give authentic information, you will be convinced. Otherwise, you will be confused. Okay. Again, more than 50% of the existing plant species are seed propagated. That is where the use of insects as pollinators has got tremendous weightage or value. Again, if you take 15% of 100 or so crops that feed the world, again 80% are pollinated by wild bees. Generally, we tend to just keep Apis cerana, mellifera, florea, or only a few, but there are many, many, many other species which we have to acknowledge because they are doing it like a chupa rustum. Again, I have to quote Hindi or Urdu here, because they are doing their job, but they are not acknowledged. So we don't know it. They are doing their work, but just because we have focus only on honey, we think about honeybees, or we have got that narrow outlook that only Apis cerana or mellifera is doing the pollination. No, like kindly change your ideas or your thought process. It is not only Apis cerana or mellifera. There are many, many other species, accounting to almost 20,000 or so species, which are majority of which are soil dwelling and which are doing their duty as pollinators. Of course, bee pollination, I don't want to exaggerate, but just because I'm just because I'm working on the bees, in some cases, up to 200% enhancement of yield has been documented in some crop. It is all scientifically proven, and that is the maximum one can generate because of pollination through bees. And of course, in 2003 valuation, so overall the global valuation of pollination. So what is the quantum, the monetary value or benefit derived by human beings because of this? It is 100 billion US dollars in 2003. That is 20 years back, it was 100 billion dollars. And in India, 50 million hectares of land is dependent on bee pollination. 50 million hectares is a huge chunk of land. Okay. And it has been estimated that bees are tapping almost 25% of the available floral resources. It is not only for crop production, mind you, please think about the biological diversity, plant diversity, ecosystem services, management of forests. Without forests, we have already faced a drought this year. So you know what is happening. So Bangalore alone, the city from which I am coming, Bangalore has got denuded by forests. The forest cover in Bangalore has reduced by 70% in the last 20 years. It is a whopping 70%. So you can just imagine what will happen to the other Western Ghats or Eastern Ghats on which we are dependent on our monsoons. Because there is a saying in India that our agriculture is a gamble with the monsoons. So we don't know when rains will come, when rains will fail. So that being the situation, again, there are thousand or more species of bee floral plants offering rich food to the bees, which are important for all the four honeybee species. And estimated losses in India due to complete absence of bee pollination will be around 55,000 rupees per hectare. This is just a very conservative estimate. So the lowest is 10,000 per hectare because of lack of or absence of pollinators, and it may go on up to 55,000 rupees lost to a farmer per hectare because of absence of pollinators. Then again, to the your global economy, if you take in 2009, there is a study by Gelai et al. Who have told that approximately 13 lakh crore rupees worth of uh, pollination services has contributed to the global economy. That is a huge, huge amount. And bumblebees, solitary bees, stingless bees are the easiest and most readily available because you can manipulate their behavior. So, of course, if you take the word manipulation, the dictionary meaning, again, the first three letters is equal to man, that is human being. And I think the most important manipulator on this planet is human beings who can also manipulate the bee behavior to suit his requirement of food and fiber. And the insects are gaining more and more importance, especially the commercial pollination services. Of course, in India, it is yet to catch up, but in European countries or American continent, there are pollination services provided by private companies. Just like they're selling your predators or parasites, there are companies coming forward to provide migratory beekeeping services or pollination services just to augment the pollination in controlled ecosystem, especially polyhouses are the controlled ecosystems where most of the crops are being grown in the cold countries or the northern hemisphere countries. And again, more than 10 to 15 large companies in Europe, Israel, New Zealand, USA, and Canada are rearing bumblebees. That is a big commercial venture. And of course, in 1992, there was 3 lakhs colonies sold at 30 to 60 million US dollars. Again, if you take it as recent as 2006, it is worth $15 billion. So this is the value of the bees which are being sold or which are being rented out for pollination in high value agricultural and controlled ecosystem and food production systems. Okay. Then again, this is just to show you that the value of rupees, I will just tell you, I will make it more desi with rupees in crores. If you just look at the third column, in USA, the value of managed pollination, only managed pollination, I'm telling. I'm not speaking about natural pollination, which goes on free of cost from nature. I'm just telling you about the managed pollination with human intervention is worth 1 lakh sorry, I may be wrong. It is 1,09,091 crore rupees in USA, 8,967 crore rupees in Canada, 22,416 crore rupees in European Union. United Kingdom alone, it is 1,120 crore rupees worth of managed pollination. Coming to Bharat or India, it is 1,68,269 crore rupees worth of pollination through managed or human intervention. Okay, so that is the value of the pollination. So if you take the current status of beekeeping in India, so almost 24% of the crop yields are the food production is again dependent on bees, and agribusiness situation is catching up. Nowadays, agriculture has also got the corporate look. I think it is catching up in southern states and also in northern states all over India because farmers cannot go on with the traditional method of crop production. They have to switch over to diversification, integrated farming systems. Corporate touch is required for agriculture. Under such situation, it has become an agribusiness rather than sustainable agriculture. That is what I'm trying to drive home the point here. And in 2005-6, 3.5 million bee colonies were available or estimated in India as compared to 2005 and 6 it was 8 lakh colonies. So it you can just see from 3.5 to 8 lakh colonies there is a increase in the number of bee colonies that are maintained and that have been documented or that have been registered in beekeeping societies across the country. Then, of course, economy, again, I can keep on giving you a lot of statistics on this. But as on January 2019, there are 9,091 registered peoples or firms who are involved in beekeeping as a business. That is the latest 3 years back or 4 years back. So 9,000 registered firms or peoples were involved in beekeeping business. This is the statistics given by National Bee Board and National Honey Mission. That is the source from which I have borrowed this information. And India has a potential to increase the number of bee colonies to 200 million colonies. But right now we have only 3.5 million colonies or 35 lakh colonies right now in India. Okay, still there is a vast scope. You just can't compare 3.5 million with 200 million bee colonies. So again, the impact of pollination on crop yield. If you go just look at the last column and the first column, in tomato, it has not been assessed, but in sunflower, more than 90% seed production can be enhanced or seed set can be enhanced because of managed or bee intervention as a pollination input. Again, in strawberry, it can go up to 10 to 40%. In soybean, it can go between 40 to 90% because of bee pollination service. In sesame, it is 40 to 90% as an oil seed. In safflower, again, it is about 10% increase in the yield because of just maintaining 4 or 5 Apis cerana or Apis mellifera colonies per acre. Okay. Again, in papaya, it is 10%. Onion, not quantified. Oil palm, it is around 10%. Mango, 40 to 90% because of insect pollinators. I am not telling it is only because of bees, because in mango, it is not the bees which are the major ones. It is the dipteran flies which are the major pollinators. Okay. And lemon, of course, it has not been quantified. Cotton, it is 10% increase. Carrot also, they have got a significant impact on seed production because of the bee pollinators. Again, in mustard, it is 30 to 60% in Punjab. Cabbage, 20 to 30%. Cotton, 18%. Orange, the fruit yield has increased by 5%. That is 30 fruits per plant can be enhanced to 150 fruits per plant just because of bee intervention, that is mellifera, I suppose, because it is USA, the data is from USA, Arizona, and mellifera is the major species in USA. Again, in sunflower, in your neighboring state, Karnataka, so the yield because of bees can be 3 times. And if in the case of absence of bees, if it is 27 quintals per 9 acre, with Apis cerana, it can be enhanced up to 67 quintals per 9 acre. So you can increase sunflower yield by 3 times just because of a bee pollination of 4 boxes or hive boxes per acre, 4 to 5 boxes. Okay. So this all I have collected over the years from AICRP, honeybees, and also the work happening all over the India and some other countries also. And of course, when we talk about the crops, the way the natural pollinators do, again, this is a photo when I was working in the AICRP sunflower. That is what I was just thinking about a short while ago. When I was associated with AICRP sunflower for about 11 years, my contemporary was Dr. Umapati sir from your campus. So both were sunflower entomologists, and that is the time when I have taken the photo. So Darseta, Serena will definitely play a major role. Even if you don't keep boxes, they will search. And oil seeds are the major mainstay for these bee pollinators. And again, this is not bumblebee. Many people confuse it. It is Xylocopa, the carpenter bee, which also plays a major role in oil seed pollination. And this is just to show you the importance of migratory beekeeping, which is very much practiced. There are a couple of beekeepers in Karnataka who do migratory beekeeping, and they are doing their business. Their turnover in some cases range somewhere between 4 crores rupees per annum to around 8 to 10 crore rupees per annum, just because they are practicing migratory beekeeping, and also they are also venturing into inputs for beekeeping sector, because they will not be dependent on only honey and selling the honey or something like that. They have to go in for ancillary things like manufacturing the bee boxes as per the ISI specifications, also supplying honey to the consumers, the wax production, value added products. If they diversify, definitely their turnover will be somewhere between 4 to 10 crores after deducting the income tax or GST, whatever it is. Okay. So this is just to show you that, and this is the study of one of my PG students on pomegranate. So he had compared Serana with enclosed pomegranate enclosed with Apis Serana colony and pollination, self pollination, and ant plus self pollination and open pollinated situation. This is just to this was submitted in 2019. MSc student of Apiculture Department, UA Bangalore. So here I just draw your attention that open pollination with red font and Apis cerana pollination, definitely they have got a positive impact and significant, statistically significant impact on fruit diameter, fruit length, fruit weight, total seed weight, total seeds per number per fruit, and of course rind thickness. These are all the marketability attributes because with which you can generally see that open pollination is the best, followed by Apis cerana pollination. Definitely, it is having a thing, and only thing you need to create a platform between the beekeeper and the pomegranate grower. So if you fulfill that, definitely both will be happy. The pomegranate grower will get enhanced in output, and the beekeeper will also get enhanced income through the not only the pollination but also through the honey and other ancillary outputs of the beekeeping industry. And again, the other qualitative full yield parameters which Mr. Kotesh Shawan did as a part of his MSc was the total soluble sugars, reducing sugar, non-reducing sugars, ash content, and TSS content was significantly higher in open pollinated, followed by Apis cerana pollination. This is just 3-year-old data. Then again, other pollination aspects. This is another student of mine who did work on capsicum. So, role of pollinators on capsicum. It was submitted in 2021, 2 years back. And here you can just see the open pollination and Apis cerana pollination. Definitely, they have got a significant, as per DMRT attributes, definitely open pollination followed by Apis cerana managed pollination will have a significant, statistically significant impact on capsicum, fruit, number of flowers, number of fruits, percent fruit set, percent prevention of percent flower drop. So these are all some of the positive attributes because of Sarana. Again, qualitative parameters like fruit diameter, fruit length, fruit weight, fruit rind thickness, total seed weight, total number of seeds per fruit, TSS content, and test weight. That is 1,000 seed weight. He has found that it is significantly higher in Apis cerana pollination, followed by ant cross pollinated crop. Of course, ant cross pollination is cumbersome. You know the labor shortage or the cost involved in labor. So definitely managed bee pollination will definitely have a positive impact even in capsicum apart from pomegranate. Okay, and these are some of the just a summary of whatever has been found out through our thesis. So it is just to show that in a vegetable crop like capsicum and also in a fruit crop like pomegranate, definitely our local species that is Serana will, even if you allow open pollination and minimize the impact of chemicals, there is going to be a positive effect on the yield and yield attributing characters of both the crops. So generally, if you just dig out from literature, what is the impact of bee visits or how it stimulates the biological attributes of a crop just because it comes and sits and does its work, foraging work, because of bee intervention, there is going to be a stimulation on the germination of pollen and receptivity of stigma, followed by increase in the seed viability, embryo, and more nutritive and aromatic fruits are going to be produced because of pollination intervention, and it stimulates faster growth of the plants. Once you get a seed which has been pollinated from the bees and you sow it for the next season, definitely the growth of the plants will be much faster. There is an increase in the number and size of the seeds, and also the yield of the crops. Of course, these are all general attributes which I have gathered from different sources. Nectar production of nectar glands is going to be stimulated. Of course, increase in fruit set, and it reduces fruit drop. I think you might have observed in crops like coconut or arecanut, there is definitely going to be, there is a flower drop or fruit drop. A small size nuts are going to be just drop out. And if you go on digging out the reason, the physiologist will give certain reasons. There may be agronomists who will, horticulturists who give certain reason. But it has been found that if bees are definitely going to do their work in such crops, definitely there is going to be better retention of the fruits, or premature dropping of fruits is going to be reduced. That is one of the findings from across the globe. Then, of course, there is going to be enhancement in resistance to certain diseases because of bee pollination or the bee activity or foraging activity on different crops. And there is a significant increase in oil and oil yield attributes in oilseed crops. You know, as I told, I think already I have shown you some certain graphs or photos especially in sunflower, sesamum, safflower. These crops are definitely waiting for the bees to do their work. If bees are going to do their work, definitely there is going to be a positive impact and a significant positive impact on their yield and yield attributing factors. And if you just look at the facts, there are a lot of data stuffed into the slide. In sunflower, research has proven 79% enhancement, mustard 55%, Niger 33%, sesamum 15%, safflower 64%, coconut by 40%, and cucurbitaceous crops by 20%. So these are all collected from different sources and put into one slide. So this is not an exaggeration just because I belong to the department or because I'm an entomologist working on bees. This is just to prove the point that bees definitely have a role or a positive impact on our food chain or our food production or productivity. And of course, I come back to the subject, the title on which I'm going to speak or supposed to speak today, that is chemical insecticides. So on one side, chemical insecticides are inevitable. Definitely they are inevitable. We just cannot say that because a country with 140 crore people, you have got 140 crore tummies to be filled every day, three times. So you can just imagine the impact of agriculture or the role of agriculture in feeding these millions. In fact, yesterday's newspaper, you might have seen that the government is seriously thinking of importing, or already they have started the process of importing many pulses because we are having a pulse crisis this year. So in such a situation, you can just think that pest management and disease management is one side of a coin. Beekeeping and pollination is another side of the same coin. So somewhere you need to find a consensus or some sort of compromise so that bees are also safeguarded and again the IPM measures are eco-friendly or bee-friendly. That is the topic of my discussion today. So there is going to be a, of course, everyone will start banging the chemical pesticides, but definitely chemical pesticides have helped India to achieve food sustainability, or it has allowed India to, earlier India had to go with a bowl to import the food commodities in 1960s and 70s. But again, now India is a surplus producer of agriculture and horticultural commodities. And I think chemical pesticides have also contributed in one way or the other to enhance food production in India. There is no fact denying, we can't deny that fact. That is a sure. But we need to have ecological imbalance. You need to use them in such a way that it doesn't impair the quality and output of the agricultural produce or commodities. And of course, you have to conserve the major pollinators and other beneficial insects, especially the predators and parasites. Okay. So when we talk about bee poisoning, again, I'm coming back to the subject. So what are the common sources? The pesticidal contamination is one major source of bee poisoning. Because again, when we talk about pesticides, just because we are entomologists, our view will be very narrow. We think about only insecticides. What about the role of growth hormones sprayed on the plants? What about the role of the herbicides or weedicides the agronomist recommends? What about the role of the soil micronutrients which the soil scientist recommends? So again, you have got the plant pathologist who will be giving you left, right, and center. He or she will be recommending the bactericides or fungicides or antiviral compounds. They are also of chemical origin. We can't just in isolation keep testing only carbamates or organophosphates or chlorinated hydrocarbons or imidacloprid and keep telling, generating data or information. We have to think in a broader perspective that all agricultural pesticides or agrochemicals, definitely they have a role in bee poisoning. Apart from that, plants also, there are some species of plants which their nectar itself or their pollen itself is going to have a adverse effect on the bee health. That is also one thing you have to think about. Then industrial poisoning. So we, again, on one side we talk about agriculture. In the same breath, our leaders or our people will also think about industrialization because you need to somewhere India needs to move forward, and industrialization is also inevitable. It is as inevitable as pesticidal agriculture. So somewhere we have to strike a balance between all these three things. And again, on the right side, you see we need to conserve the bees. So it is a great dilemma because the day is not far off if we decimate all bees. I think Einstein, he is a physicist, he is not a biologist. and he has told very convincingly that if you kill all the bees on the planet, we will have food security left for another 4 to 5 years. It is not an exaggeration because it was told by a physicist, not a biologist. If it was told by a biologist, you might have taken it with a pinch of salt, or you might have suspected it because he belongs to the biological science. He might have been trying to defend his subject, but it has come from the mouth of a physicist who has he thought about it. The philosophy of bees, he has immersed himself. He has thought about it somewhere about 50 or 60 or 70 years back. So if you look at that, definitely that picture, what it is a painting actually, and it is very convincingly told by the young boy or young girl that bees are required. So that is the take home message for all of us. Then again, you know the type of pesticide mortality which bees are going to be susceptible. There are stomach poisons, there are fumigants. So you know how the trachea or the spiracles are going to be disrupted, are going to be suffocated because of fumigants, and stomach poisons, you know how they are going to affect the midgut epithelial cells, which are the digestive areas of the insect gut, including the honeybees. So, so once they gain entry, definitely there will be multiple modes of action. A contact action chemical can also have a fumigant action, or a fumigant can, once it enters, it can also serve as a nerve poison, or once it enters, it can also serve as a stomach poison. So we need to think in different perspectives about a particular molecule. We don't know once it is let out of the can or a container, you don't know what type of action it is going to have or impact the insect or the human being, especially on the health of the concerned insect or the concerned human being. And of course, there will be alteration in the physiology of the gut. The entire physiological mechanism of the insects is going to be altered because of chemical intervention. And again, if you take crop-wise consumption of insecticides in India, I'm talking only about insecticides in this case. It is 2013 data given by Food and Agricultural Organization, Rome. So plantation crops consume 8%. Cotton takes a lion's share of 54% of all insecticides applied in India. And others, it is 8%. Fruits and vegetables, 13%. Rice, 17%. If you just keep aside rice because it is not subject to bee pollination or insect pollination. All the other crops put together, you can just see it is accounting for 83% of the total insecticidal consumption in India is bombarded on all important value-added commercial crops, vegetable crops, fruits, plantations, spices, and so on and so forth. You can just look at the impact of chemical insecticides. Okay. And what are the factors contributing to bee poisoning? Again, there is contamination. The open flowers are bloom. So that is the time when the bees come. When the crop is in the vegetative stage, I don't think the bees are much bothered about the vegetative stage of the crop. When it is in full bloom or the flowering peak, that is the time when the bees are coming to the flowers, and that is the time the insecticidal applications will play a crucial role. So if you are forced to apply a chemical, especially on flower feeding insects, or again if you take Adisura atkinsoni or Helicoverpa parmigiana or Spodoptera litura, I think they will come on different stages in different crops. So you will be forced to apply, and if at all the crop is in bloom stage, definitely it is going to affect the bee activity or cause immense death of the bees. Then residual exposure. So sometimes we have to think about residues also. So because we might apply now, but we don't know what is happening to the residues of the chemical, because there are reports that DDT, which was applied during 1960s or 1950s or 1945, even now if you take it, if you examine the mother's milk, definitely there are bound to be traces of DDT, which was applied long back, about 50, 60 years back, because they enter the ground, they enter the soil, they enter the geophysical cycle, they enter the biological systems, again they come back into our food chain or into our food web. So what I mean here is, it may not be directly visible, but the residual toxicity will be indirectly doing its harm over the years across a plethora of areas, including different landscapes, including agricultural and horticultural landscapes. Then air temperature, of course, definitely the low temperature is found to increase the bee susceptibility to chemicals. So low temperature in conjunction with chemicals, low temperature with chemical insecticides is known to trigger or increase the susceptibility of bees to chemicals. And timing of applications, generally it is recommended that apply, if you are forced to apply a chemical or if it is inevitable for you to apply a chemical molecule in the field, the best from the perspective of beekeepers, it is the best time to be done, it is during the late evening or the night time, because at least for 10 hours until sunrise the bees are not going to come out for foraging. At least until then the insects which you are supposed to kill, the pests which you are supposed to kill, or the diseases which you are supposed to control may be affected positively, and the bees will be at least will not face the major brunt of the chemicals at least for 10 hours or 12 hours. So that is the idea here. So the most dangerous period is when the early morning or the morning hours, because the bees will be in full strength. You know, the worker bees, almost 80 to 90% of the colony will be going out for foraging except for the nurse bees. And the most dangerous period is early morning or morning hours. And of course, they have characterized across many research papers. If you dig out, dusts are the most tremendously, they are the most toxic as far as bees are concerned. And of course, relatively the most safer, I cannot call it as safest, at least if you call them as relatively safer, granules are the relatively safer method of application of chemicals. So what may be the reason again? Because granules will be applied to the soil. Bees will be foraging at least 3 or 4 feet or 6 feet above the ground. That is one plus point. So with that in view, or because of the scientific data that has been generated over the years, so dusts are the most hazardous, followed by wettable powders, flowable concentrates in that decreasing order. Then when we talk about colony strength, so generally the weak colony and strong colony, if you compare, the stronger colonies will lose more and more bees if they are impacted by chemical insecticides. And you may ask why weak colonies escape, because they have nothing to lose. Already they have lost most of their colony members. They are not willing to come out and lose more members out of their workforce. So bigger colonies with more number of foragers are more susceptible to the impact of chemicals. And the distance, you know, by now most of you are aware that the flight range of a bee will be maximum 1.5 or 2 to 2.5 kilometers. If it is the bigger Dorsetta can fly at least to 2.5 or 3 kilometers, but the moderately sized or medium or small sized bees, it can fly only up to maximum 1 or 1.5 kilometers. So if you want to spray something, at least the distance will really matter. If you are really concerned about the bees, you can shift the colonies at least for 1 week or 10 days so that the negative impact of the chemicals can be curtailed. And again, you can bring back the boxes back to the original place. And of course, the age of the bees is also one important thing. So DDT, dieldrin 7. So newly emerged bees are more susceptible, especially nurse bees are more susceptible to the organic chlorines or the chlorinated hydrocarbons, and older bees are more susceptible to malathion and methyl parathion as per the in literature published over the years. Then of course the body size is also one of the important factor. So smaller insects require a small quanta of the chemical to kill them, and bigger bees can tolerate to some extent. So moderate to more, they can survive for a longer time, even if they are exposed to the same quantum of chemical. Then of course, one thing, I think my talk will be incomplete if I don't touch about neonicotinoids, because that is the biggest threat to the bees so far. And most of the European Union countries, including Australia and Canada and American continent, the advanced, so-called advanced countries, definitely they have taken lot of regulatory or the mechanisms to check or to prevent or somehow curtail the use of the neonicotinoids. Especially, they have found that it is one of the major reasons for colony collapse disorder, that is CCD, which is an AWAC in those countries. And the European Pesticidal Agency Authority, which has curtailed the registration itself for majority of the neonicotinoids. And of course, this is just to show you the impact of neonicotinoids on mellifera, one slide, on serrana, the another slide. So generally, when we talk about the neonicotinoids, the clothianidin, dinotefuran, imidacloprid, and thiamethoxam are highly toxic by contact and ingestion also as a stomach poison. And they are also absorbed by the plants and they get metabolized over the period of time. But of course, thiacloprid and acetamiprid are found to be moderately toxic to mellifera. That is what the results are showing. But of course, the breakdown products will also be toxic. So once it get metabolized either in the plant system or in the metabolic system of the bee, definitely the breakdown product also will be toxic to some extent as far as mellifera is concerned. Again, if you when we talk about bumblebees, there is a negative effect of neonicotinoids on food consumption, reproductive attributes, survival rates of the workers get depleted, then colony survival is affected, and foraging activity is affected as far as bumblebee, that is bombus species, is concerned with regard to clothianidin, imidacloprid, dinotefuran, and thiamethoxam. Then for solitary bees, again solitary bees also play a major role in pollination, as I told in my earlier statement. So clothianidin and imidacloprid are found to be highly toxic to the blue orchard bee, that is Osmia species, and also the leafcutter bee, which is a major pollinator in alfalfa. And imidacloprid again will affect the alfalfa foliage and indirectly it affects the alfalfa bee. And of course, sublethal amounts are also going to have harmful effects on the osmia and other solitary bees as far as neonicotinoids are concerned. And of course, when we talk about what it actually does, so neonicotinoids may synergistically interact with demethylase inhibitor (DMI) fungicides. So each one will try to provoke or enhance the effectiveness of a fungicide or the negative effect of a fungicide on the bees. That is what it has been proved in laboratory tests. And of course, bees and both the social bees and solitary bees are going to be affected. Of course, when we talk about the nobody has in fact taken seriously the impact of neonicotinoids on smaller bees, especially stingless bees. I think earlier the same department where I'm talking, Dr. Muthuraman sir has contributed immensely for stingless bees. I am aware of that. So when we talk about neonicotinoids are such deadly chemicals, so I think that is also an eye opener. We can do more research in those areas because stingless bees are often ignored because of their small size or just because they don't give us much honey, we may be ignoring them, but they are contributing in their own way towards medicinal honey and also towards conservation of biodiversity. Okay, so this is just to drive home the point. Then application methods. I think when I talk about aerial application, I think all of us are aware about the impact of endosulfan in our own neighboring states, both Kerala and Karnataka. The endosulfan was sprayed aerially, which was not meant to be for aerial application. You know what? How it impacted? It was sprayed aerially mainly to control the tea mosquito bug, that is Elopeltis anthony, in cashew plantations. So in Kasargod of Kerala and coastal districts of Karnataka, it negatively impacted the human beings also. Rather than controlling Elopeltis, of course, Elopeltis control was achieved, but at what a cost? So almost 30 or 40 years of litigation went on in the Supreme Court. I think recently they have given some compensation or something, but when lives are lost and when agony is there, giving compensations will not fulfill anything because already the damage would have occurred. So aerial application is the biggest potential risk as far as bees are concerned. Again, from Elopeltis anthony, I again come back to the bees. So drift is one major concern. So you may not be involved or you may not like to spray, but the neighboring farmer who is spraying will unknowingly or knowingly, he will allow the drift, and because of the wind force, it will come and drop on your colonies or on the crop in which your bees are foraging. So the drift is one major threat. Apart from that, aircraft application is the most hazardous. Then core sprays are more hazardous than fine spray droplets. That is what has been proved scientifically. Then this is just to show you that uh, a list of highly toxic chemicals. So again, I have dug out from some website. So some of the chemicals have been modified, have been classified as highly toxic, some chemicals as moderately toxic, and some chemicals as relatively safer. So only there are bees have got only two options: the devil and the deep sea. So there is no third option. But for our satisfaction, we have classified them. The human being has classified it into three categories. And if you just look, there are many new molecules and old molecules. And even carbonyl, as I have put it in red font, it has recently been banned. So apart from that, there are many molecules which are still in the market, which have not been banned, but they are highly toxic. I don't want to read through this list and uh, consume the time. So apart from highly toxic chemicals, there are relatively non-toxic chemicals. That is why I've given the green font. So among that, you can just see azadirachtin, Bacillus thuringiensis. So they are the toppers. Probably they are arranged in alphabetical order. So whatever it is, you can just make out that there are relatively safer molecules, but only thing we need to have the will and we need to have the skill to use them at the right time, at the right place, in the right dose. So there are molecules which you can use them to be safe, and you can also achieve pest management in the same application. Of course, indiscriminate application and discarding of the containers is also one major threat. That is what I want to highlight here. And you know, farmers are often fond of uh, applying. If you give a recommendation of 1 ml per liter, if they are not satisfied, they will go for 3 ml or 4 ml per liter of a particular molecule. That is always there with the farmers because they want the pest to drop dead right in front of them. Until then, they are not going to be convinced with our recommendations. So that is one thing. Then there is a cycle. So whatever molecule you add to the soil or to the plant or to the ecosystem, with through recycle, through precipitation, through evaporation, through groundwater recharge, through your borewell, through your water, it is again going back. And whatever karma we do, it will follow us. In the same manner, whatever you apply into the soil or into the air or into the crop will come back to us. This is just to show you the pesticidal cycle and what are the signs and symptoms. So generally, one major signs and symptoms are there will be excessive dead bees in the hive entrance. That is the most common symptoms. But we have often ignored that large number of workers don't at all come back. They would have lost their way, or they would have died on the way, or they would have died in the vicinity of the crop in which the chemical it has been exposed. So those things we tend to underplay or we tend to ignore because seeing is believing. Only just because we see dead bees in front of the hive, we panic. Then we realize that something has gone wrong. But the culprit will be the chemical which has been sprayed 2 kilometers or 1 kilometer away from the hive on the crop. So that is one thing. And generally, they have categorized the normal mortality is if there are 10 dead bees per day in a particular colony, it is called normal mortality. If there are 200 to 400 dead bees per day, we call it as a low mortality. And if there are 900 bees per day, moderate mortality, more than 1000 bees, we call it as a extremely high mortality. That is how generally bee safety classification has been categorized based on the number of dead bees you can count in or close to the vicinity of the colony. Then what the bees do? The bees become aggressive. Mortality is one thing. The bees become aggressive upon exposure to toxic molecules. There is a impairment in the communication behavior. That is, the dance language will suffer. They cannot communicate effectively or more forcefully to their nestmates or to their co-workers. And there will be stupefaction, paralysis, and of course, all these, most of the insecticides, the same symptoms you would have observed even in other insects. This applies even to the bees. There will be abnormal, jerky behavior of the abdomen, then rapid movements, and of course, they become very aggressive or angry. That is one major thing. Every day you would have tended to them. But once they get poisoned, they sting the beekeeper who attends to them almost every day in and day out. So that is an abnormal behavior. Then queen may stop her egg laying or it may reduce their egg laying capacity. Then regurgitation or vomiting of the gut contents by the workers who are exposed to the chemical insecticides. Then a large proportion of workers die because their paraglassa or glassa gets protruded out, and emergency queen cells are going to be created because they know that some crisis is going to happen because of queen death, or they get punked or afraid, and they create more number of queen cells because queen is going to die or get killed because of the molecules. And queenless situation will often produce more drone brood. That is also one tendency. Then young bees feed on contaminated pollen and they are going to die. And finally, there will be super seizure of the queen because the queen dies. Definitely, another queen is going to take over. That will be the super seizure. And this is one photo showing the malformities or deformities in the bee morphology or anatomy because of carbaryl or ethiprol. So when brood was poisoned, you can see the impact of brood poisoning on the adult bees. This is just to show you the malformed bees. So it is a poisoning of brood with carbaryl, ethiprol, beta-cyfluthrin plus imidacloprid. So these are the ill effects on the brood expressed in the adult workers. And of course, again, I repeat, abdomens get distended, bees become aggressive, regurgitation of gut, guard bees get confused, brood chilling and dead brood can be seen inside the colonies, and queen fecundity is greatly impaired. So these are the overall pesticidal poisoning symptoms. And of course, Indian regulatory mechanism is there. You know how the Central Insecticide Board functions. So there are some molecules which have been completely banned with effect from 1/1/2018, and the usages of some molecules which are completely banned from 31 December 2020. So you can see there is a list of 18 plus 12. 30 molecules have been banned. Of course, not all of them are insecticides. There may be other molecules also in this group. But overall, government is having a regulatory mechanism to reduce the impact of toxic molecules on the ecosystems. And how do we prevent? So far, I have told you the problems, but what are the solutions? Definitely try to use low hazard molecules or materials. The chemicals which are less toxic or relatively non-toxic you have to use. There are options, and you know, if you take the LD50 of in terms of milligram per B, if it is 0.001 to 1.99, it is highly toxic. If the LD50 is more than 11, it is relatively less toxic to the bee. So that is how you can classify a molecule as B toxic or relatively less toxic or highly toxic. Then use of low hazard methods of application. So systemics injected to soil are much safer than spraying them on the plant. So this is one method of reducing the impact of the molecule. And of course, all said and done, we can tell everything in the classroom or in the seminar hall with a colorful PPTs. But what happens in the agricultural field or horticultural ecosystem, that is left to your imagination and how the farmer handles it. Okay. And you know the impact of neonicotinoids, it is going to be translocated through the plant system, and each and every nook and corner of the plant, including nectar, which the bee forages. Though you apply the imidacloprid to the soil as a seed treatment or a soil application, definitely imidacloprid will be there in the nectar in a few hours, and it will have a negative impact on the bee. Okay. And aerial application, which is the biggest threat, just to show you that. Then use of lower hazard formulations. Again, I go back to my earlier slides. Avoid using dust when bees are actively foraging. That is the one take home message. You can use other methods like applying granules or solvents or oil based formulations, which are relatively safer. Then the low hazard timing. Chemicals break down in few hours. So such molecules can be applied in the night so that by the morning, when the bees come to forage, the low hazard molecules get broken down during the night or get metabolized. Then removing the weed flowers. Of course, bees also visit weed flowers when there is a crisis for the nutrients. Definitely, they will go forage for nectar and pollen in the weeds also. So you have to, including manual weeding is also one method of preventing the hazard due to weed flowers, and modifying the spray program in relation to the temperature. Then high temperature will cause the bees to forage early in the morning or late in the evening. So you accordingly adjust your spray schedule or your spray timetable so that the bee hazards can be minimized. Then using non-selective insecticides and IPM, again, I come to that, reduce or minimize the use of chemicals. Not that you can totally remove chemicals. You should try to minimize their use and try to use safer molecules. And of course, there will be dumping of pesticidal containers or the used containers. So that is also one threat. You try to avoid dumping them. Try to bury the containers after they have been used. So India is still, so in some patches people try to reuse the containers, especially pesticidal containers should not be reused because the bees will be unknowingly they will try to think it is a liquid or a nectar or a water source and try to take the liquids from the empty containers of used pesticides. Then you should try to have forage preserves or areas which are uncontaminated with chemicals. Especially for the bees, you have to raise them and allow the bees to forage in such areas. Then, of course, if you want the colonies to recover from the shock or the impact of negative impact of molecules, you can feed pollen or pollen substitutes or pollen supplements, feeding sugar syrup, giving adequate clean water for their sustenance, adding the bees, or trying to unite colonies. A weak colony should be united with a strong colony. Protect them from the vagaries of the weather, that is heat or very low temperature, and moving them from a pesticide treated area to a pesticide free area. That is what I call as migratory beekeeping if it is feasible. If it is not practically feasible, at least for few days, 7 days or 6 days, you try to shift the colonies to a safer place 2 or 1 kilometer away, and again you place them back after the negative effect of the molecule has subsided. And of course, I come to the last part of the lecture. So IPM, of course, IPM we keep telling, but to what extent the farmers are practicing, that is a big question. So here the components, you know, you are aware by now because all of us are entomologists here. Cultural, mechanical, physical, biological, legislative, and of course chemical methods are also there. So planting resistant varieties or cultivars is one method. Discouraging pests by the way in which you design, the way in which you irrigate, the way in which you fertilize, you try to discourage the pests from entering your area. That is one method of managing the pests. Then altering the crop environment so that you deprive the pests of their food material so that they go to other areas. Keeping the pests out of the field by barriers, physical barriers, screens. So that is what I told in the beginning. So why farmers are switching over to precision horticulture or high-tech horticulture? Because they are unable to grow their crops in open field, because they are again subjected to virus vectors, thrips, whiteflies, mealybugs, aphids. They are all transmitting the viruses and other deadly diseases. So that is why farmers are switching over to high-tech or precision horticulture. So that also comes into one of these. And of course, wherever possible, you can use low cost or no cost methods, washing off the pests, pruning the pest parts, trapping them, pests. These methods you're all aware, but try to convince the farmer. That is the way we can move forward. Then biological control, managing pests with minimum use or no less usage of chemical pesticides, and use chemicals only if it is inevitable. Then use of least toxic and most effective material. And of course, soaps, oils, and microbials can be encouraged. This is one method. And of course, this is just again, I come back to some high value crops or high profile crops wherein definitely there is a long standing technology. The PDBC or NBAIR has given major IPM biological control based IPM modules for many crops. It is always there, but it has remained in the books. So try to bring it out into the field, and especially for sugarcane, you know the impact of Trichogramma chilonis, Japanicum, and the sequence has been standardized. The dosage has been standardized. Not only in sugarcane, I will also touch upon cotton, maize, tomato, rice. There are a plethora of biological agents and all the dosages have been standardized. Only thing, the availability of parasites may be a hindrance or it may be a bottleneck. So if we try to overcome these constraints of availability of biological control agents, definitely biological control has got a immense potential to safeguard these. Always we in entomology class we talk about PQ, pollinators, predators and parasites. So if we use these biological control methods, definitely pollinators, predators and parasites can be managed more effectively to enhance the crop yields. And of course, using pesticides only when needed, only when pest reaches economic threshold level. Otherwise, just don't recommend or don't try to encourage farmers to use the chemical insecticides. And of course, applying at the time of blooming should be discouraged. Don't apply pesticides when the crop is in full bloom or partially bloom situation. And apply pesticides which when bees are not foraging. Again, I repeat my earlier statement. The late evening or the night time application. Of course, there are practical difficulties. You may ask the question: how the visibility is poor? How can a labor can spray a chemical or insecticide during night time? We have to switch over, or our mental block should be removed. We should search for newer ways or sustainable ways for protecting the bees. And late evening hours or early evening hours we have to apply. Then, of course, do not contaminate water bodies, because all of us are dependent on water, because without water there is no life. Even the bee life will be impaired tremendously. So don't try to negatively impact the water bodies or contaminate them with deadly chemicals. So pesticide labels should be notified. The hazards should be read out. It, of course, everything is there in the theoretically, but when it comes to practice, most of us fail in the practical applications. Then using less toxic formulations, using emulsifiable concentrates which are less hazardous to the bees, granular formulations which are safer. These are some of the alternative approaches with which bees can be safeguarded. Using ULV formulations is highly hazardous. It can be avoided wherever it is feasible. And of course, notifying the beekeeper. So if you want a beekeeper to be successful, he should be communicative. He should know what is happening in this vicinity. He should know what is happening in his neighborhood. So he cannot be ignorant. Though the agriculturist or horticulturist may not tell him that he is going to spray, we should know what is happening in our neighborhood. And only if there is good communication, the bees can be protected. And of course, confining the bees to the hive box. If it is an inevitable spray has been applied in the neighborhood, you have to forcefully confine the bees to the box at least for 2 days. Provide them with sugar bowl, syrup bowl, and the pollen supplements or substitutes, and make them to be indoors at least for 2 days. Of no, I know it is very difficult, but still to save them, we have to do this. I think I will thank the bees and also you for your tolerating me for the 1 hour. Thank you. Sir, I think one of the areas which we are lacking is the negative effects of chemical herbicides or weedicides, negative effects of bactericides, fungicides on bees. I think most of us have ignored. I think even I could have taken it up now, but now even in fact, I thought even for my next student, I think even I am thinking in these lines, because nobody knows or it has not been documented. I think even if you search probably on herbicides, someone might have worked. So there is a huge lacuna as far as research topic for entomologists as far as herbicides, weedicides, bactericides, and fungicides and their safety to bees. I think that is one area, researchable area, which the entomologists can take up. And apart from that, there is another major thing going on is the species. Again, if you take Serana, we need to go for molecular taxonomy because so far when we were students like you, we felt Serana has got two strains. One is the mountain strain and one is the plain strain. But now there is again there is a churning happening in the taxonomy of Serana. So again, it has been bifurcated or it has been renamed. So one in the one darker strain is named after as one species, and the light colored Apis cerana strain has been named as a different species. So again, these areas you need to work out. And again, as far as Tetragonula, the stingless bees are concerned, many people we have read in the scriptures or we have read in the published information that people who are recuperating from the cancer treatment or who have undergone chemotherapy or radiation therapy, if they take or if they consume the tetragonula or trigona honey or stingless bee honey, they are going to revive or they are going to recuperate. So these areas can be touched upon. So is it really true? So if that is the case, to what extent? Then you have to collaborate with the medical science people to some extent, probably with the Ayurvedic physician or a allopathic physician. And again, another area is the area which there is a lacuna is venom extraction. Of course, for mellifera they might have done. And what is the impact of venom on the health and nutritional aspects? Definitely, there are some medicinal aspects of venom. So, if we collaborate with medical people, definitely we can throw more light on. There are no questions. I will thank once again. I express my gratitude to TNAU for inviting me to serve as an external examiner for the PhD student Mega Vijayan. I also profusely thank the head of the department of TNAU Department of Entomology. I also thank my close friend Dr. Umapati sir, Dr. M.R. Srinivasan sir, Dr. Johnson sir, and all the faculty members, all PG students, PhD students of this department. And I also wish to acknowledge earlier Dr. Jairaj. He used to conduct many training programs for budding scientists and entomologists. In fact, I also had an opportunity to listen to him several times. So, of course, I immensely thank each one of you for giving me an opportunity to share my small amount of knowledge. Jai Hind, Jai.